Hello everyone. So in this video we are going to look at arrays and pointers and how we use them in Arduino programming language. So as you can see on the screen I have defined two separate arrays. First one consists of characters and the second is made up of the data type integers. Now first let's print the array on the serial monitor. So I am printing the entire array serial.print ln arr1. So I expect the entire array to be printed on the serial monitor, and yes, it is happening as you can see. Just a second, there is some error here. I'll try to re-upload the code and I'll clear the serial monitor so there is no confusion. So yes, as you can see, uh, the entire array HELLO is being printed on the serial monitor. uh, So array is a data structure which is used to store multiple elements in a consecutive manner in the memory location. So each of these elements H, E, L, L, O will be stored consecutively one after the other in the memory. So now if we look at the pointer section, there are two symbols which we use. Uh, One is the ampersand symbol and the other one is the star symbol. So let's demonstrate using an example. I'll uncomment this section of the code here. So there is an integer value 32 which is stored in the variable n, and now we will be printing the value of y on the serial monitor. So here as you can see this statement int y is equal to ampersand n. We can read this statement as y is equal to address of n. So the variable y will get the address, the memory address where 32 has been stored. So let's upload this code. We expect to get the memory location at which 32 is being stored. So we are getting 256 on the serial monitor, which means this is the particular memory location where this integer value 32 is being stored. So this symbol helps us to get an idea where our element is being stored actually. So let's see another example. I'll uncomment this section of the code as well. So what we will do is we will use the other symbol, that is the star symbol here, and we will try to print the array, the entire array, using the address of the memory location only, without actually accessing the variables. So I'll just upload this code and then I will make you understand what is happening. It is taking a little longer to upload the code. So yes, as you can see, uh, the characters HELLO are being printed on the serial monitor. So actually what is happening here is that uh, first we are accessing the memory location at which each and every element of this array ARR1 is being stored. So this part will give us the memory location at which the element is being stored, and the star symbol uh, denotes, we can read this statement as uh, the value at this location. So this will fetch the value at this particular location, the location which will be denoted by this part, uh, and that will give us the entire array on the serial monitor, as you can see, right? So now let's try to print uh, the memory location at which these arrays are stored. So I'll uncomment this code as well. This will be array 2, and here I'll do one thing. Okay, so now this will give us locations at which the elements of these arrays have been stored. Okay, so let's compile this code and see what we get. So we are getting the values of the array. We didn't want that. There has been some, okay, this is the mistake here. I had to add the ampersand sign here. So now we will be getting the values at which each and every element 26, 24, and 38 have been stored, the memory locations. So the code is being uploaded, just a second. Okay, so now as you can see, we are getting 256, 258, and 260. So these are the particular locations at which these three numbers have been stored. So now you may ask that these aren't the consecutive memory locations. If it starts from 256, then it had to be 256, 257, and 258. But it doesn't work that way, since integer has a range from 32k to plus 32k, which is actually 16 bits. So it uh, takes about exactly 2 bytes of memory space for storing an integer value, and that's the reason each and every integer value is taking 2 bytes of memory location. So 256 and 257 are the memory locations where the this first element is being stored, 26. 258 and 259 are the memory locations where the second element is being stored, and so on. Right. So if we want to see where the other array is being stored, we will do one thing. We will add that here as well. So it is equal now we will print the memory locations at which the second array elements have been stored. Just a second. I forgot to comment this. has been some mistake here. I'll re-upload the code. So as you can see, we are printing the memory locations at which these elements of the array have been stored. So by looking at this, we can say that 256, 258, and 260 are the locations where the three integers have been stored. And the other locations, I think I had to increase this 3 to 5, or I'll do one thing. I'll use a separate if loop to demonstrate the different locations uh, where these elements have been stored. So this is the second array. So we need three elements here and five. So this will give us a clear picture about the memory locations. So as you can see, uh, 262, 263, 264, and 265, 266. These are the places where the characters have been stored. Just a second, I think the first element is missing here, that is 256. Okay, no, it was right the first time. So yes, these are the different memory locations where the array elements have been stored. So this is how we use pointers to access the memory locations and to change values without tampering the variable itself. We can also do that as well. I'll show you by an example. So we have n is equal to 32 here. So I'll do one thing. I'll write here int x is equal to ampersand uh, n. This will give me the memory location at which n is being stored. First of all, I'll print n here, and now I'll try to change the value of n without actually changing the variable, but only modifying the value at which at the memory location where the value of 32 is being stored. Right. So we will will define a new variable here, which will also get this memory location of n, and then we will try to modify as empty. Okay. And now we will try to print the value of n. So this won't be necessary now, and I'll just comment the other parts of the code now. There has been some error here. I'll just try to re-upload the code. So now we are getting 20, and I'm pretty sure the first time we used the serial.print n, we were getting 32. So what we have done here is we have changed the value of variable n without actually touching n, but only by tampering its memory location, by accessing the memory location and then modifying the value there. So this is how we can use the pointers. So that's it for this video. If you have any doubts, you can ask us afterwards or comment below the video. Thank you.